All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we're still going over our malaria training covenants module. Let's have a look at what we went over today. Now, yesterday I did inform you that we're going to have to crawl through these last few steps because of the computational problem we're having, the CPU versus the GPU. So let's just dive right in and pick up where we left off. I'm actually going to start compiling now so we can get things moving and see if there's a big difference with the things I read to you. So yesterday, if you recall, these are the three epics we ran as opposed to the 100 with the standard models version. And today we have the three models or the three epics that we ran using a Linnet model. Now, if you watched yesterday's episode, you know why we used the Linnet model. So we're going to pick it right up where we left off. So this was the first epic we ran here. It had a loss value of 9.8 with a validation loss of a 2.0. When we got to our second epic here, we had a loss value of 1.2 with a validation loss of 7.7. And then by our third model, we had a value loss of 5.5 with a validation loss of 3.8. Now notice, hold on, let me go down. Notice that by the third epic, our model was training quicker, and the difference between the value loss and the validation is much closer. And what I mean by training quicker is this. So for the first epic, as you can see, it took 11 seconds per step to train our first epic. It's same thing for the second epic. It's 11 seconds per step. But by the time we got to the third epic, we took 3 seconds per step to train this epic here, and we got a lot closer with our validation loss, with our value loss. So yeah, we got quicker with our training, and we got more accurate with our training by the time we got to the third epic. So I'm assuming that if we had more epics, which we can't do because of the computational problem, we probably could train a lot quicker, and we probably could train a lot more accurate. But with that being said, let's move on. So another thing that we could do to make debugging faster is take off the validation value data. Now we don't want to lose the original code, so we're creating alternative code without the validation data set. So you can see line 165 for the commented out original and line 166 for the updated version. So let's look at that while it's just compiling. So you can see here, this is the original commented out with the validation data still inside, and this is the updated version that we're going to be using today without it, in the hopes of making everything run quicker. And everything did start running quicker, so let me start running through these pictures here. And again, these are our images of our cells that let us know if the cell is either uninfected or parasitized. And if you recall, this is exactly why we're using the Linnet model, because the Linnet model is used or is mainly geared toward images. And we do have 16 images to train here, or we have multiple images, but these are the 16 that we're running through. So yeah, that's why we're using the Linnet model, because it's geared towards using images. So yeah, we have to get through this, and then we'll actually get to compiling the code or the piece of code that we want once we get through the 16 images. I don't know if that was all 16. We'll see. Then I can pick back up the reading. Okay, yeah. So that was everything with that. So let's go back down. I showed you that. I showed you the updated line. Okay, also we're going to change all of the sigmoid activations into ReLU activations except the DITS1 layer. And we will also reduce the kernel size from 5 to 3, 84, 88. And lastly, we'll add batch normalization to our model. In batch normalization, all values belonging to the same batch are standardized. See lines 86, 90, 96, and 98. Since all of these take place within the same area, I'm just going to show you everything at once. So as you can see here, we have a kernel size of 3 now. It was 5, but we changed that to 3. Also, all of these ReLU activations were actually sigmoids, so we changed all of them to ReLU, but we left the dense1 activation a sigmoid. And lastly, we added batch normalization to our cov-d, and then we added batch normalization to our max pool d. So yeah, that's that. Now we can recompile our model with the updated data. So as you can see, it's still moving very slow. So I'm not sure that really helped us. Again, this was just for demonstration purposes. We didn't have to take any of that stuff off or change any of that stuff in our model. We only did that in hopes of making the model run quicker. And again, the instructor is using the Jupyter notebook, and I'm still using my VS Code. So I'm not sure if any of that stuff actually helps or pertains to me. But yeah, as you can see, it's running pretty much the same in our book. It's saying it's going to be an hour and 12 minutes before even the first epic is trained, and we still have 3 to go or 2 more to go after this one. So imagine if it was the entire whole 100 epics that the instructor is using. We'd be here for days, like I said. So like I said, I just wanted to give you an update. These are steps that we didn't have to take. Like I said, I could have skipped over these steps. The only reason I'm going over these steps is to get a handle on everything and to get a visualization of everything, to see how things actually move and operate in one environment opposed to another, and to make sure I go through all the steps so we make sure that we have a handle on everything. We can see firsthand what happens when you run into certain issues, how to fix those issues, and how to navigate around those issues. But we will pick it up tomorrow. And again, we'll probably be crawling most likely still because we still have a little more left to do in this module before we move on. But I will keep you guys posted every step of the way. But for now, this is the Python Poppy. You guys stay Gucci.